Hi there, in this video I want to cover some important concepts that are confusing for newcomers in the Java language. When you're first starting out in Java, you may get to a point where you can program a loop, maybe read and write data from files and if-else statements and so on, but eventually you need to step out of the baby crib, and so to speak, and involve more classes and objects to write larger applications. And that could be a challenging leap for a lot of people because it involves digging a little deeper and understanding really what's going on behind the scenes when a Java application is running. So that's exactly what I'm going to cover here on this whiteboard, and we're going to go over concepts like what's an object, what's a class, but more importantly, where do these objects come from, where do they go, what's the heap, what's the stack, what is garbage collection, what's application runtime. You've got reference variables, instance variables, local variables, all of this terminology. I'm going to demystify it here for you in this video. Alright, so let's start from the very beginning. You open up Eclipse or IntelliJ or whatever editor IDE that you use to write Java code. When you open that and try to create a class, right, that class is not going to have anything else in it. It's just going to have the keyword class, the name of that class, and open and close brackets, okay, with no code. It's an empty class. When you hit the run button in Eclipse or any editor, it's going to complain. The Java interpreter is going to complain. It's going to error out. It's going to say, okay, you have this file. What do you want me to do with it? Right? Because there's no instructions in there. And this is an important point. In Java, instructions, code needs to be wrapped inside of named blocks. Right? You could think of these as methods. Okay, everything in Java, the instructions to the computer on completing tasks should be inside of methods. Okay, methods are what do all of the work in a Java application. So for example, if I have an empty class with no methods in there and I try to create a loop and do some kind of calculation, that's inaccurate Java code. It's not even going to compile. Okay, you can maybe declare some variables, but that's it. You can't do much more than that. So that's an important point to keep in mind. Methods are what do all of the work. So when you hit the run button, and the interpreter complains, hey, I don't know what to do with this file, it's looking for a particular method, okay? And that is called the main method. That's the starting point of every Java application, is the main method, okay? So I'm going to write some code here, and you can actually copy it and paste it into your main method of any class and run it, and it should work. It should work. Okay, so anything I write on the board here, code, assume that I'm writing it inside of the body of the main method. Okay, so let's go back to when you hit the run button. What really happens? Well, there are two memory locations that become reserved for your Java application to run successfully. Okay, and these are resources of your computer, your RAM, and one of them, you can think of these as memory areas. Okay, reserved for the successful completion of your application. One area is referred to as the stack, and the other memory area is referred to as the heap. So I'll go over each one of those individually. Let's first talk about the stack, okay? And I'm going to draw it out here, stack. When you hit the run button, the first method invocation is, of course, main, right? That's the starting point. So what's going to happen is a frame is going to be created, right? And you can just think of these frames as sort of memory areas inside of this stack memory area, right? It's further breakdown. Think of these as slots. And we can say main here to indicate that this frame belongs to the main, right? So all of the variables inside of the main method, those are local variables, local to the main method. Okay, so inside the main method, all the code that I'm going to write here, consider again, is in the main method. If I create a variable of type int, let's say it's called age, right? The interpreter is going to go line by line executing my code. Okay, when it gets to this declaration of a variable, what's going to happen is in the main frame inside of the stack, a specific reservation is going to be made for this variable, okay? And that's going to be called, of course, age. All right, so you can think of this little box as a reserved place to maintain the data for the age variable, all right? Now on the next line, I can just assign age any value, for example, 12. Or sometime later in the program, I could change the value to 15. Okay? And this particular slot in the main frame, age, it's going to continue to change, right? That's where the data will be maintained, all right? So that's really what is referred to as a local variable, okay? Now, let's say we are past this point and we have another method invocation inside of main, all right? Let's say we have some method called do work, all right? When it gets to this line here, the do work is going to be added to the stack, okay? It's going to be piled on top of main, right? Do work. And inside the body of this method, wherever this method is defined, inside of the body of the method, there may be local variables there too, right? It could be of type integer, of string, or any other object type variables. We'll go into those in a little bit. But those variables are going to have reservations in this frame, in the do work frame, okay? So let's say in this do work method definition, there's some variable called wait, okay? And that variable is going to have a special reservation here inside of the do work frame, all right? And let's actually define do work. I'm going to, for brevity, I'm not going to enter all of the other keywords that are required, like public, void, and all of that. Let's just say this is the method definition, right, of do work. And in here we have a variable called wait, and it's of type float. Hopefully you can read this. And let's say it's 120.30, okay? So this variable is going to reside in this stack, the do work stack, okay? And inside of this method definition, I can further invoke other methods. Let's say we have some method called do more, okay? Let's say this method goes out to the internet and downloads a bunch of files and enters them into the database or whatever it is that it does. While this method is executing, of course, this will also be on the stack. All right, this will be added on top of the stack, and it's going to be called do more. And whatever variables that are in this method's body, right, those are local variables, they will be reserved in, they'll have special reservations in this frame, the do more frame, okay? So once do work is complete, right, it moves down to here. Do more's frame is going to be eliminated from the stack, okay? It's going to be gone. And the next thing on the stack is, of course, do work, all right? So once do work is completed, once we exit this method, then in the main method, we're ready to move on to the next line, and do work is now complete, okay? So now in the stack, do work is going to be eliminated, all right? And now we're back in the, on top of the main, all right? We're still inside of the main method here, okay? I can define a variable here called, name, string, name, and there's going to be a special memory in here, special area. Let's just say it's an empty string, name. There's going to be a special area for this particular variable name. I'm just going to draw it. I'm just going to put some scribble there. Just consider that as the name variable, all right? So this is the purpose of the stack. It maintains method invocations, okay? Method inside of a method inside of a method, right? Those calls are going to be piling up on the stack. And when that internal method is complete, that's going to pop off the stack. When the next wrapper method is complete, that's going to pop off the stack. When the application is done running, we're of course done with the main, then main is also gone from the stack and all of the memory is clear. It's available for us to run other programs, all right? So stack, that's the stack in a nutshell. Now let's move on to the heap, okay? And we are still inside of the main method here. I'm not going to erase this stuff. Let's just erase this. We don't need do work anymore. We've already executed it. So let's say we are going down in the main method line by line and we come across this code, we have car, and the variable name is called my car. This is a local reference variable. Okay, this reference variable belongs inside of main. Okay, and I'm going to create a slot for this, of course, and this is going to be called my car. So at this point, in this frame, special memory is reserved for being able to maintain the data for whatever my car is going to have. Okay, and this variable is going to point to the actual object. Okay, right now we haven't assigned it anything, we've just declared it, right? And the slot has been created in the frame, but we have to assign it a particular object, and you've seen how to do that. It can be my car is equal to new car. So this car is not a primitive data type, it's a complex data type. It's a class, a type, okay? Somewhere in our application there's a class defined that has the specification of what cars are supposed to do, right? And this variable my car, right, does not actually contain the object. Okay, this is a very important point. A lot of people get confused. This is not a regular variable. This is referred to as a reference variable. Okay, it refers to where the actual object resides in memory. And this brings us to our next point. The actual object that's created with this new keyword, new car, resides in the memory area, the other memory area that I was talking about, the heap. So let's draw that. All right, consider this to be the heap. All right, at this point we don't have an object yet at this particular line, but when we get to this line, we do have an object that gets created on the heap, and that object is triggered by this new car command. So we have a car object. All right, and this my car variable, right, inside of the main frame, the main stack frame, is now going to point to car. Okay, so what really gets assigned to this my car variable is not the actual object. What gets assigned to it is the memory address, all right, on the heap where this car object resides in memory. That address is the thing that gets assigned to my car. All right, that's a very important point. It's different for primitive data types. Age, when we assign it a 12, the variable actually equals the 12. When we give it age, the variable actually contains, the number 15, right, in binary form, but that's not important. It actually contains the data. In this case, my car does not contain the actual object. It contains a reference, right? The address for in memory where that object is located. That's what this guy contains, right? So if I was to create, assign my car to some other object, let's say my car, on the next line, my car is equal to new car again. All right, now what's going to happen is, instead of this my car variable, which you could probably barely see, but this memory location in which my car data is supposed to be there, instead of that pointing to this particular car object, we have another car object that has been created. All right, and that is because of this line right here, this command. All right, and now my car is not going to contain the address for the old object. It's actually going to contain the address for this new object, right, in the heap. So this is where we come into garbage collection. Okay, once we pass this point, once we're done here, we move on to other finer things in the program. We've completely lost track of where the old car object was, right? Remember, we've assigned my car variable a new address of where the object resides. So we've completely lost all connection and communication with this old car object, right? So this is actually, you can think of it as a rogue object that's a candidate for being deleted, right? This is where garbage collection comes in. Garbage collection is a process that runs in the heap, and every so often it comes and looks for objects that don't have any relationship to them, right? Any variable that's pointing to them. It looks for those objects and it eliminates them to clear the space in the memory, all right? So this car object, this poor guy, is going to be destroyed, right? And we have reserved more memory, right? The whole reason for the garbage collection process to exist is so that we can save memory for future bigger and better things. If we left that car object in the memory with no variable pointing to it, obviously it's useless to us, right? It's not going to ever be used. We can never access it. Why is it there? It should be eliminated. That's where the whole garbage collection concept comes in Java, okay? So hopefully this all made sense. We talked about primitive data types and we talked about class types, right? This car. And we also talked about local variables, right? These are all essentially local variables to the main method, right? In this particular frame on the stack. But we also have something called reference variables, right? And those are, this, for example, my car. This is, even though it's local to the main method, this my car is not containing the actual object. It contains a reference to where the object is on the heap, okay? That's a reference variable. So there is one other type of variable that I want to discuss, okay? And that is referred to as the instance variable, okay? So let me erase some of this stuff and then we'll go over that. An instance variable is exactly what it sounds like. It's a variable that belongs to a particular instance, okay? We can have many instances of the same class and all of them will be uniquely identifiable by the data that is in their instance variable. So essentially a class with some variables in it, those variables are instance variables, and when you create an instance of that class, you can modify the state of that instance by changing those variables. Okay, so let me explain to you what that means. We haven't created the class car that we saw earlier, so let's create that class and we'll go over some more examples. Class car, and this of course is outside of the main method, so you can go ahead and create that car if you haven't already done so. And in the main method we're going to be actually creating instances of it. So the first thing I want to add to this class for now is just going to be an instance variable of type int, and it's going to be called HP, which represents every car has horsepower, so that's basically what that's going to represent. And we're not going to add any other methods to this for now. And let's create an instance of car. So we can do car, and I'm going to call it my2car, just so that it doesn't collide with the previous variables that we've defined, is equal to new car. All right? When I create an instance of this, an object, or an object and instance, these two terminologies are used interchangeably. They're essentially the same thing. When the interpreter sees this line here, an object in the heap is going to be created, and it's going to be of type car. Okay, a car object. And this particular variable is going to contain the reference to where that object is on the heap. And of course, this variable is in the main frame of the stack, so we can have a little slot here, and we'll say it's my2car. All right, this variable is going to contain the address of where this car object resides. And by the way, now that we have HP as an instance variable belonging to every single object that we create of this class, it's going to have a special slot on the heap that is going to be used to maintain data for HP for every single object. All right, so I'm going to put this in HP, and let's give my2car some horsepower. So we can do my2car dot HP is equal to, let's give it 120, and this particular data is going to get 120. This variable is going to get the data 120. All right. Now let's create another instance. We could do car my3car is equal to new car. Okay. At this point, a variable is created here in the stack frame, my3car. Okay, and this variable is going to contain the address, of course, of where this object is created in the heap, right? And that object is right here, car, and it of course has to maintain a slot for HP, right? And let's give my 3 car its horsepower to be, let's make it super fast, 1,000. So this value here is going to contain 1,000 as the integer, okay? Now, what I want to get into, so hopefully you understand what an instance variable is. An instance variable is used to maintain state for that particular object, right? These two are car instances, right? Each one has its own variables maintaining their particular state, all right? I want to go into one other thing, and that is an instance variable that is not a primitive. This is a primitive data type, but is a complex data type. Let's say we have some other class in our Java project called engine, all right? I can actually create an instance, or rather an instance variable that is of type engine, and we'll call it my engine, okay? We're not going to instantiate it here, we're going to do it in the main. So let's say I want to give a car an engine. I could do, for example, my 3 car. I can say my 3 car dot my engine an engine. Oh, which engine, right? Where's our engine? We haven't created an engine yet, right? So we need to first create an engine object. This is just a reference variable. It doesn't have any data assigned to it yet. So let's create the engine first, the object, and then assign that to that particular variable, okay? So it's going to be the same approach, of course. Engine, we can call it big engine is equal to new engine. And since we're in the main here, this variable, of course, is we need to place in the stack frame called big engine. And of course, this new command here, new engine, creates an object, right? So that object will be appeared here on the heap. So let's create that. All right. Here's our engine. Sorry for my handwriting. Okay, so this big engine variable contains the address of where this engine object is on the heap, right? So now I can assign this variable to my 3 car dot my engine, right? That's the variable name, right? My engine. I can give it big engine. So what exactly did I give this thing? I didn't give it the actual object engine. I didn't really give it that. I gave it the reference, okay? I gave it the actual address in memory on the heap where big engine resides, right? So, by the way, now that we have another variable to maintain in the car class, we need to have 2 more slots here to maintain engine data, okay? And they're going to be called my engine, my engine. Okay. Now the car that we're giving an engine to, my 3 car, is the guy that has 1,000 horsepower, right? It's a super fast car. So we're actually going to get this engine. The address of where this engine object belongs is going to be assigned to this car. This instance is my engine variable, all right? Sorry for the handwriting, but hopefully this makes sense. It's pretty self-explanatory, and we're going to be seeing plenty more examples in the remaining screencasts. Thanks for watching.